And we're live. And hello and welcome. My name is John Stevenson. Welcome to another Clojure virtual study group. Today we're going to talk about apps with maps. So we're going to play around with maps and build a little app, build a simple little encoder, decoder using Clojure and probably using a map as well. Excuse me, my voice is a little bit croaky. I was speaking too much last night at the London Java conference.
Too much. There's no such thing as too much speaking, John.
Well, probably too much speaking in the social event afterwards.
You must have had a good time.
It was really good. It was very enjoyable. I learned lots. I'm going to share my screen, so we're going to get the trippy pattern for a second, and I'm going to hide this. Wee. There we go. Okay, so yesterday I actually did a similar discussion around maps for the London Java Community Conference. So if you go to the live code, so this is live code samples. This is what we're doing today, and yesterday there's a session here. So if you go into the YouTube live link, I'll change this to the recording link. It's the same link, but you can go and see the previous video I did on maps, which we do a little bit of work with nesting maps as well. You don't need to kind of see that beforehand, but it's a useful reference if you do. And today we're going to, I wrote a blog article on this Clacks interpreter. If you've ever read Terry Pratchett, which is books I recommend. There's a Discworld series. In one of the Discworld books, he has this Clacks tower system where they communicate using light patterns. So we're going to convert our messages into light patterns or a representation of those light patterns, and then simulate the encoding and decoding of those messages as well. So that's today. So let's switch over to Emacs. Questions? Yes, that's good to see. If you do have any questions, please feel free to add them to the live chat of the broadcast. If you're on the Hangout, then just feel free to ask me questions directly. And if you're on the Hangout, if you could mute yourself so while you're not asking questions, that would be great as well. Okay, so what is a map? Just to recap, if you've never seen any Clojure before, we can define maps using the curly brackets. And a map is a hash map, it's a dictionary, it's essentially a key value pair. So we have a key here, and we have some kind of value, which can be a string, it can be any kind of legal value. So this is a value. It could also be, you can also use anything for keys. You can use a string for a key. Excuse me. So I can have, this is my key, and it can even have a function as a value, or even a key as well. So as long as it returns a value, which they all do, then you can use a function in there as well. Obviously, it's more of a rare case, but if you wanted to generate something, a function, you call a function with an argument, and that will be a legal value as well inside the map. So it's quite flexible. And as you can see, we don't need to actually specify any types with our map. We can simply build and define a very kind of meaningful data model, basically just using keys and values. And it's quite common to pass JSON around. And if you look at JSON and a map in Clojure, conceptually they're just the same. They've got key value pairs. Syntax is slightly different, and obviously you can do a lot more with a Clojure map than you can do with JSON as well. but it's very easy to convert between the two if you need to export your maps into JSON as well. Okay, so let's have a look at how you would actually build maps in Clojure, really. So some examples. Here we've got a bit of a Star Wars theme this morning. Apologies if you don't like Star Wars. We've got basically 3 individual characters, and we represent each of those as a keyword, and each of them has a value. In this case, the value of the Luke or any of the characters has got a full name and a skill. We could also have we could break full name down into first name and last name if you wanted to as well, and we can then put that map into give it a name, because obviously typing that map around in our code is time consuming. So we want to kind of have a nice reference, a simple reference to that map. So if we use a def function, we're defining a name that points to a value, and in this case the whole map is the actual value itself. And then we can go in and get information from that map. So if I evaluate Star Wars, there we go. So now it's in the running REPL I have in the background of this editor, and I can evaluate the functions that work on the map. So here we've got the get function. So it's saying get from this map the value that the keyword Luke points to, and because that value that the keyword Luke points to is a map, it's returning a map. But we might want something inside the map, so we can also do we could wrap that result in another get statement as well. So this line here, oops. So this line gives us the map, and then from the map of full name and skill, we then just choose the skill value that we actually want. So we get the map for Luke, and then we get the skill there as well. So there we get just the skill for Luke. You can target swamp rats. That's again a movie reference. If you've never watched Star Wars, that's pretty meaningless to you. But I hope you understand the principle of how to access that value from the map. And there's a nicer way to do that. Rather than doing multiple gets, you can walk the path to the right value by using the getIn function, which is a variation on get. So here we're doing get in on the map Star Wars characters, and then want to find the Luke value, which is a map, and then from that map we find full name, and then that's a string, so we're just going to return that string. So if we evaluate that, then we get Skywalker is the full name of Luke. And we can also use skill, so the keywords. Sorry, we use the keys if they're keywords. So if these keys are named with a colon, a double colon at the start of the word, that makes them a keyword. So this is actually a keyword type. We go in and check the type here. So we do type skill. You can see this is a specific type of value, so it's not really a name. It's a bit more than that. It's a keyword in Clojure, which is essentially a name that points to itself. So we can basically use it as a lookup or anywhere in our code, and it's usually associated with something else. So in a map, it's associated with its value. So therefore, we can use that keyword as a function to go and look up values in maps and any other data structures, really. But we can also use it as a function. Shush, kitty. Sorry, I've got my cat joining me today, and he's being fed. Meow. Shush. Sorry. Sorry, excuse me for that.
Maybe he wants to do some closure.
Maybe he does, yes. He doesn't want to do some tail recursion. No. There we go. Where were we? Yeah, so rather than doing lots and lots of multiple gets, we can use get in from the map, and then we can have a path. And this path can be as deep as our nesting of our data structure is in terms of maps as well. If we want to add things to maps, so we've got a here we want to change we basically want to update and change what the skill of Vader is in this map as well. Let's take that out of the way. At the moment, we've got Vader and who likes doing crank phone calls. I'm not sure where I got that idea from. I'm going to evaluate this and update that. And now we see that Vader's skill is the dark side of the Force, which is a recurring theme in the movie again. So I've actually updated the map, but actually, if I leave that as a comment in the, so I'm just going to evaluate it and get it to print out as a comment. And so here, it's a different skill. There we go. However, maps are immutable. So how does that actually work? So if we actually look at, we go and just evaluate Star Wars characters. Let me move that up. We can see that Darth Vader has still got the previous value in there. So we haven't actually changed Star Wars characters. We've actually just generated a new map, which has got a new value in there. And that's what happens when you actually run a function over a collection, in this case a map. We're actually, if we're altering that collection, then we're actually we're creating a new copy of that collection. And so we can use associates if we're just going to replace it with a value. There's also update if we want to update an existing value with a function. So if we have say we have a map that has a value of 1 in there, we want to update it to 2, we can update it with the increment function, for example. What else have we got? Yeah, and you can get as complicated and as nested as you want in there. You can combine maps on with vectors as well. So here we've got the Star Wars universe, which is made up of characters and ships. And then inside the characters, we've got Jedi, Sith. So we've got different clans and different families of characters here. And so the Jedi are represented by a vector, an array-like structure. So we could just basically list out all the Jedi quite easily. And so on and so on. And same for the ships as well. But there's lots of different ways to model this as well. So the vectors are quite simple for just grouping things together, and maps are useful for if you want to define specific data, as it were, or around your data and structure it so it's kind of has some built-in meaning. It's a bit harder to define meaning inside a vector. It's a much more simpler structure as well. So you can basically prop anything into there as well. What else have we got? I think I've already covered this. Yes, I've got a bit of duplicate code there. And as well as using get and get in to get the information, you can also use the map itself. So here we're using the map as a function. And we're also using the keywords here as a function as well. It's quite useful if you're going to do a little inline function, a little lambda function that's just going to be used once, and you don't want to write a kind of external function, then these are kind of a nice shortcut to use. So we're getting the same results. We're still getting the same results out of these things when we evaluate them. still getting a map here as well. So this is a slightly short way of doing it. If we want to get the full name of the map, so it works exactly the same as the get in that case. Yeah, if you're doing an inline anonymous function, then that's a much shorter kind of syntax and sometimes easier to read. If you're not sure, just stick with the get and the get in. It's generally more readable, although eventually you'll get used to this format as well. You can use a threading macro as well if you're going to push your data structure through multiple functions. Then sometimes it can make it a bit easier to read what this is doing using a threading macro. So the threading macro is just this dash arrowhead character. It's basically saying take the value of this first expression, which Star Wars characters, when you evaluate that, is just going to return the map, and then it's going to pass that as the argument to the next function. So we're using Luke, the keyword, as a function, and it's going to be, and we would put the map here where these three commas are, and then it would evaluate that as expression. In here, we're seeing that it's doing it several times. So we put the whole map, the whole Star Wars characters map here. Then we would put the result of doing Luke, running the Luke keyword on that map into the full name, and we'll get the full name back here as well, just to show that. Oops. Yep. Okay, there we go. So we still got Luke Skywalker as well. So there's a few different ways of doing things in Clojure. It does depend. You would kind of use get by default, and then these if you were using a nested, kind of embedded kind of anonymous function, and these if you were doing multiple functions running on top of your data structure or data structure as a result of another function call. So let's do a simple exercise to get us going. Is there any questions so far? There's no questions on the live chat. I'm not sure about the Hangout. Any questions on the Hangout? No, doesn't sound like it. Excellent. Okay, so I had a thought about doing a little ASCII code generator. So if you've not come across ASCII codes before, so it's the number representation of characters that computers use. So, for example, the lowercase value of A is ASCII code 65. I think that's right. I'm sure that's right. That seems to be right.
Yeah, that's correct, John.
Thank you very much. Thank you. That's good to know.
You add 26 to it, you get the ASCII character of a capital A.
Interesting. Good to know. Actually,
I kind of know the ASCII characters for quite a few of them. Space is 32.
Yes, because there's 26 characters in the alphabet, obviously, and so the capital letters follow the lowercase letters. So we could memorize it, memorize all those values, or we could have a map and use that map as a lookup code, so we didn't have to remember them all, or to use the map to teach the computer what they were, or teach our computer program what these values are. And so here we've got so I've defined ASCII codes as being the number of the code and then the value it represents. So 65A, 66B, 67C, and so on. And we could type in all the codes we wanted to, but that's a lot of typing, and don't need necessarily. We can get the computer to generate it for us if we wanted to, if we think about it. So this is the idea of this little challenge, is to generate an ASCII code range just for a particular alphabet. So here I've defined an alphabet, and we've just put that as we can either define the alphabet as individual strings, So yeah, individual strings that represent the letters of the alphabet. We could have this as just a whole string, or we could have it as individual characters. So quite a few different ways to do it. Here we've just put them all into a vector, or we just have them as a string and split them all up. I can probably do that. I probably don't even need the spaces. So here we're using a regular expression. So closure string split is a function that will take a string and then an expression on basically a pattern that will decide how we split this string. And in this case, we're defining the pattern with a regular expression, and you denote a regular expression with the hash and then a string as a pattern. And our pattern in this case is just a space, because we've got spaces between all our characters. So when we evaluate this line, we get basically a vector of strings. We basically get what we get up here as well. This is just another way to generate it. So you wouldn't have to just, if somebody gave you a vector or basically a string of your alphabet, you can convert it into a vector of strings inside the vector as well. So how are we going to generate this? So we're going to generate a hash map of our ASCII codes. And so we're going to assume that we know that the fact that we're starting at A, and that value of the ASCII code is 65. So we're going to pass that kind of assumed knowledge into the function we're going to write. And then we're going to basically take the alphabet that we defined and basically add a code value for it that we're going to generate, really. And then it'll put the pairs into a hash map, into a closure map, and return that as the answer. So let's have a look how we did that. So create a function called generate ASCII codes, and it's going to take two arguments. So it's going to take an alphabet, and it's going to take code start. So this is the numeric value where the code itself starts. The ASCII code starts, and so we've got our alphabet here, and we've got our range. So range is going to give us a range of numbers. So if we just did range by itself, that's a little bit dangerous because it will just generate an infinite number of integer values. Unfortunately, my computer does not have a memory capacity of infinity. That would be quite nice, but also probably infeasible to actually deliver. So I have to go and make sure that I don't kind of generate infinity range. So you can actually give range some arguments. If I give range an argument of 10, and it actually generates all the numbers from 0 to 9. So it's exclusive of the value you actually give it. So if you do range 10, it's 0 to 9. If you do 100, it'll be 0 to 900, it'll be 0 to 99, and so on and so on. And you can also give a start value. So if I do 100, but then I give it a start value of 50, then it's going to generate just a range between those two values, so 50 to 99. It's a nice simple way of generating a simple sequence of numbers. If I wasn't sure how many I wanted to generate, then I can use things like take a number of elements from a collection. So if I wanted to take 10, and then I could safely use range by itself, because range is going to act lazily. If it's going to lazily generate a sequence of numbers if it's got some context. If it kind of knows that it only needs to create 10, then it'll only generate 10 numbers. So if we do this now, then we should get the same result as the just doing range 10 as well. There we go, and I haven't blown up my my stack, which is also very useful. Okay, so that's take. So that's different ways we can generate a sequence of numbers. So that's and our ASCII codes are a sequence of numbers. So this particular part of the expression here, we've got range. We're going to start at value 65. Actually, that should be, rather than hard coding it, that should be, we can put that as code start. So I'm going to change that word to code start. That's going to be, well, if we pass in, if we call this function like this with an alphabet and with a value, then code start is going to come in, and that's where we're going to start the value. Unfortunately, there's no way to just give range a starting value and get it to generate. So if we're going to provide a start range, then we need to provide the end value where range would stop. And so we need to do a little bit of calculation to figure out where that was, because we don't know, we might not know how many values there are in the alphabet. So what we're going to do is first we're going to calculate the alphabet. And then, so English alphabet, as we saw before, is just a vector of numbers. So we've just got a vector of our ABC and so on. So we can count those and see how many there are, and then we know how many numbers we need to generate using range, and then we just add that, the value of count of the alphabet to code start, which would be 65 in this case, and that's the end range. So when Clojure comes along, it'll read this and say, oh, okay, well, I'll work out what the end range is, and then I'll be able to generate range from code start to the end range, and then I'll be able to have two collections that are the same length, and then I can use hashmap to generate a map. So if you've got, so rather than just using the curly brackets to define a map, you can actually go in and say, well, I've got some numbers, I've got some values in a vector. So I've got oops, let's make that A1, 2. So I've got some values in a vector, but I want to specifically turn that into a map. Then I can use the hashmap function. Then as an argument, I'm going to give it that vector. And this will now generate me a map. Oops, what did I do? Oh, does it need to take separate values? Maybe it does. I think, oh yes, it does, yes. Oops, so not in a vector at all. Let me get rid of the vector. That's what I wanted to do. Yeah, so it's taking individual, so hashmap takes in individual values of individual values, and those values need to be in pairs. So previously I was giving it a single vector, which is not a pair. Even though the vector contained pairs, I actually have to give it specific values. So now it should give me a map. And you see there's no guarantee of order in the map, but then it doesn't need to be specifically ordered for like most situations when you're using a map, because what you'll do is use the keyword to find the values, and you can pull out all the keys from the map as well very easily. If I wanted to do, I just wanted to get the keys, so I knew what the structure of the map was, and then there's a keys function. And evaluate this, it'll just return the keys that are in the map, and then there's A and B as keys as well. So if I wasn't sure what a map contained, I can easily go in and interrogate it and say, what are all the keys Or I could even just do the values as well. So if I do vals, that should return just the values of all the things in the map. Well, 1, 2. So with that knowledge, then we can figure out how to combine alphabet and range. So as we discovered before, I can't just give hashmap a value like a vector value. So I can't give it a collection; it has to be individual values. So what we're going to do is use map function, not map the data structure. We can use map the function to create a hash map from each of the individual elements of alphabet and range. So it's going to go through and pick up A from alphabet, and it'll pick up 65 from the ASCII characters, and it'll put them together as a key value pair in the hash map, and it'll keep going through until it comes to the end of whichever is the first of these data structures. So by the time it comes to the end of alphabet, it'll be at the end of the range of numbers anyway, and then it'll just return everything as a map, as the key value pairs. So I didn't actually evaluate this. So let's evaluate that function. Oh, did I call alphabet something else? I think I did. Looks like I did. What did I call alphabet? Oh, no, I forgot to evaluate English.
English alphabets is unevaluated.
Yes, thank you very much. So it's evaluated now, and then I can evaluate the function, and then I can evaluate a call to that function. So now we've got the function defined. I'm just going to take 2 arguments. So we call the function and give it the English alphabet, which we've just evaluated, and the start point of 65. So again, we could change where we could create our own ASCII codes. Obviously, that wouldn't be particularly useful necessarily, but we can generate our own ASCII codes by specifying whatever value we wanted to start at. And so we evaluate this, and we should get our alphabet. There we go. So, but it's all individual. It's all individual maps in this case. So we would need to, instead of using map, I think we can use something like ZipMap. There we go. Let's reevaluate that. And if I remember correctly, hopefully this gives us the right results. Oh, yeah. Oh, interesting. Did I? Yes. So why is that not working? Let's do some live debugging. So what are we complaining about with ZipMap? Because it's working with a wrong number of arguments. Oh, okay. Oh, ooh. I wonder if we could just use ZipMap instead of hashmap. Interesting. Good. Go. Awesome. So, ZipMap is a kind of a variation on map. So ZipMap is actually going to do, is kind of doing what map was doing. So like when I was mapping hashmap over it, it was creating individual maps as a result and just putting them into a vector. I'll just show you that again, I think. So if we did map and hashmap, and then we do evaluate this as a comment. You can see, so we've got a list, and the list is composed of pairs of maps, and we don't want that. We just want a single map. So we want to basically flatten them. We could, we might be able to use flatten as a way to do that. the map, hopefully. Let's pull that in, slurp that in, there we go, and let's see what we get. Oops. Down to this function, and no, that didn't work. Okay, so let's, oh, did I? Get rid of that for a second. You can't flatten it.
You had an extra bracket there after flatten.
Oh, I didn't select flattening. Okay, that might be why. There we go. Just if you're paying attention.
And you got to slurp it in, then it'll work.
Thank you very much. Yes, I think I missed. I didn't slurp in properly. I think that's
yeah, breakfast time.
Breakfast time. There we go. There we go. So if I evaluate this now, hopefully we get the right. No, it's still not flattening it. Oh, because it's in a list already, so the list is already flattened. So there must be another way to do that. That isn't going to help us in this case. So we can use, so let's look at ZipMap in a bit more detail and see what that does, because we know that works. So rather than creating individual maps by using hashmap, we want to do that, but we want to combine them all together, and instead of putting it into a list, we want to combine it into a map. So there's a really nice function called ZipMap that helps us work that. So let's look through what ZipMap is doing. So ZipMap is taking two collections. So in this case, we've got a collection with a keyword in and a collection with just a string in. So when we do ZipMap, then it's going to create a single map for us with those values, and yeah, it's just going to return the pairs here. And if there's an imbalance in the number of values in one collection versus another, it's only going to take as many as there are in the shortest collection here. Although we've got name and address, there's nothing for the address to match to, so that just gets dropped because we can't create a map that's got a single key without a value in it. It has to be a pair. And we can do ZipMap here for which is generating some ranges. So we're just generating these, and it looks like it's something's missing, but it's just because they're not in order, not in numerical order here. So it's just generating pairs of numbers. These two ranges that we're generating. I'm not sure we did that before. Oh yeah, here we're just converting string. So the numbers, we're just converting those into strings. We can do stuff, and we can also convert them into keywords. So if we wanted to create keywords for our map, then this is how we would do it. We could basically generate the here we're generating strings by just mapping string over each of the values in range. Here we're going a bit crazy here. So we're mapping string of that range of numbers, and then we're converting the strings into keywords by mapping keyword over each of those values as well. And you can see it's very easy to kind of create and transform the contents of a map, or contents of any collection, just by using the map function with another function that transforms it to something else, transforms each of the elements to something else. And so back to ZipMap, we can we can generate this range. So we create a map by getting taking this here. This function takes in the size of the map that we want to generate, and then we're going to define keys and values. By values is just the size, range, the size of the map. So it's going to generate a range of numbers. And here we're applying the keyword to the same thing as well. So this is we don't need to create convert them into string first. We can just create them into keywords. So we're basically going to generate a range of numbers, and then we're going to apply keyword over. So apply keyword is just basically going to apply the keyword function to each of the numbers in that map and generate it. Generate two. So this will generate two collections, and then we could use ZipMap to join them together. I tweak them as well. Oh yes, and then I realized that okay, this I think the apply didn't quite work very well. So it's in. So we're generating numbers of strings, and then we can convert those strings into keywords, and then our values are just the numbers, and then we can basically zip up the numbers of keywords with the values, and we can get our keyword of 0 and number of 0 and so on and so on. So it generates a nice map for us. That's an example about how ZipMap is working. So if we go back to our, if we go back to our ASCII code generator, so rather than ZipMap, rather than mapping hashmap over here, which generates the individual maps, if we delete ZipMap, and give them this function, then now we get our map, just a single map with all the key value pairs in there as well, just not necessarily in alphabetical order. If I do P, B, oh, okay. So here it's a bit easier to read if I just pretty print them out. So you can see it's key value pairs, and yeah, we can see they should all be there. There's 6, so they're all there. Which is nice. And we could generate them here. We've generated them so they're like you're looking at them up by the letter, and then you get the numerical value of the actual ASCII code. So if we wanted to know what D was, it would be 68 and 78 and so on and so on. Any questions? No questions on the chat. Any questions in the Hangouts? All fairly simple.
Yeah, fairly simple question.
Okie dokie. Good to know. So I'll publish all these code snippets and put links into the study guide as well, so you'll be able to review the code and also play around with it as well. And so the final thing I was going to do, so we've done that, haven't we? Yes. The final thing I was going to do was, oh yeah, the Clacks editor, coder, decoder. So if I so go back to the, oops, go back to the browser, and go back to that one. So yeah, we should have a chance to start this anyway, and we might leave the complete solution for homework. So I had this idea of this Clacks interpreter. It's just a very simple encoder decoder challenge. There are more interesting and more involved ones, but this is quite simple. It's just basically converting messages. So messages are basically a collection of characters. So each of these characters has a conversion. So just like ASCII code has the letters, each letter has a value. In this case, each letter has a light pattern. So we just need to figure out how we're going to represent this light pattern in Clojure, and then use that to convert messages backwards and forwards as well. So we need to figure out how to represent a clack. We're going to call so each pattern for each character, we're going to call that a clack, because it's the Clacks system. and we want to figure out how to represent it. So in this case, we want to figure out how to represent light patterns. So there's 6 elements in the pattern, so how would we represent that? So each of these has like 6 little lights that can be on or off. And so one of the things we know from computing for on and off things is binary. That's the simplest kind of representation for on and off that I can think of anyway. And so we can have 0 to represent off, and then 1 to represent on. And so then we just need to represent the actual the overall pattern in some kind of format. So in here they're all kind of listed as like two rows of 3 lights or 3 rows of 2 lights, depending on how you look at it. So we could map that specifically. We could have a vector of vectors, and so this represents the first column, and this represents the second column of lights. And then we could define each of the individual characters as a def. That would mean we'd have at least 26 defs in there, which isn't necessarily kind of the most common approach to doing Clojure, to doing data structures in Clojure. It's much more common to have a single data structure inside your namespace and have those functions in that data space, functions in that namespace work with the data structure. So we could do this for testing purposes as we kind of delay the final decision about how we're going to do things in there, and we could go in and check. We could run a function on there, go in and check whether the current character we're getting is A, and then or current character matches the pattern, and return that as well. So we need to kind of decide how to kind of basically create a character to clack. It's a lot easier if we take the message. If we have a message that we want to send and we want to break it down, it's a lot easier if we break it down into the specific characters and then convert each character, and then we want to decode it. We can just reassemble, convert each code, each light pattern back into the code, back into the character it represents, and then just join them together as a message. So let's have a go at that. So if I create a new project, so let's see, where are we? The project is going to, let's go into and clean space. There we go. Pretty good. So I'm going to start this. I'm not sure if I'll have time to finish this, but we'll start it. And if I don't finish it, I'll cover it in the next video. So let's create a new project called Clacks. And so we're just using Leiningen to create a new project, and we call it Clacks. And it's just using, by default, it's just using the default template. So it's just going to create a very simple project. And then if we go into Emacs, and then we can open this project up. There is one I did earlier as well, so you can also go and look at that. Let's open the source, Clacks, and then we're going to open the core.clj file. There we go, and it doesn't do an awful lot, as it says. Let's make that bigger so we can all see. There we go. Very big. So we've just got a simple namespace, clacks.core. So Clacks is the folder that this is in, and core is the file name. So it's core.clj. So it's core is the namespace. We've got a function here that doesn't do a lot. It's not very useful. So I'm just going to kill it. So the first thing we want to do is figure out how to represent our Clacks. So if we look back at the pattern in the web page, so we've got 0, 1, 0, and then 0, 0, 1 as the pattern. If we read it that way. So we could have 0, 1, 0, 0, 0, 1. We could represent it simply just by having it as a pattern of numbers. We don't necessarily need to kind of represent the way it's visualized in there, because we can easily break that down into a different instruction, setting it a tree and making it so we could. I mean, we could have it as if we did put it as a vector. I don't think it's really adding anything to what we want to do, and we want to make it equal to A. So we know we can if we use maps, we can map things together. So if I did A as a let's see, if we did it as a keyword, then that value would be that value as a there, and so then we basically then have a lookup in our map. So if we wanted to get the value of A, then we could quite easily get that from looking up at this, using this map as a dictionary, as a lookup table. So if we do from the map, we pull the map in, and then from the map we want to get the value of A. Then when we evaluate that, it's going to return a cider session running. Oh, because I've opened a new project, so I'll just start a REPL for this project, and then we'll be able to evaluate it. So it just takes a couple of seconds to fire up the old JVM. I'm just going to save the file in the meantime. There we go. I think that's done. Just thinking what time. There we go. Ooh, what? Oh, has that converted the? Oh, that's converted the number. That's interesting. That's very weird. Interesting. How did I get? Oh, yeah. So it's converted the binary. It's not using a binary representation. So perhaps putting it in a vector is not the best idea. So we can, instead of a vector, let's Control K that. Maybe we could just use a simple string and 001. And there we go. So a lot of the design around Clojure is to figure out what the best data structure is that you want to manipulate from. And so this is an example of how we've basically taken the map and played around with it by applying functions to it to see which is the most appropriate way to represent the data in a map. And this is kind of like the really basics of how to design a Clojure project, a Clojure data structure, or how you design your data in Clojure. You basically very quickly kind of go with some ideas about what you want to do, and then you can very easily test those ideas of structure. And sometimes you might want to kind of tweak how you represent things in your data structure, whether you want to use maps and vectors and so on. And this is all kind of driven by you just experimenting in the REPL. So you can kind of think about what you want to build, do some whiteboarding, kind of think about what the data is you want to actually represent and manipulate and transform, and then put those ideas into the REPL. And you don't have to spend ages discussing which is the right form. You can actually just put different ways of expressing the same data into the REPL and test them out with some either some tests or some functions, and it will guide you into helping you make those decisions about how to structure code and build data structures in Clojure pretty quickly, because you get the fast feedback in that way. Okay. Any questions about that so far? Nope.
Sounds good.
That was good. Excellent. So
the only comment I had is, why are we not generating these ones and zeros using a iteration kind of a code structure rather than trying to use maps?
That is a good question. Could we generate these things as well, like we did with the ASCII code?
They look like some binary representation, right? Maybe there are two different sets of binaries incrementing, but maybe they can still be generated rather than hard-coded.
Yes, yeah, that would be excellent if we could do that. So I haven't actually gone through these to work what the pattern actually is. So it doesn't seem to be kind of a sequential pattern to these things. These have all got two. That one's got three, 4, and then back to 3. So I'm not sure if there is a sequential pattern that we could actually do that, because you need to know. So like if it was just a sequence of integer kind of values that we could just generate, that would be very easy. If it was following some pattern like the in the previous video we did yesterday, that we did the Fibonacci sequence. So that's a well-known pattern. So if these lights were represented in that well-known pattern, then we could certainly generate it. So that's a really useful idea. And maybe that would be something we discover as we're experimenting in the REPL. Yeah, it's I guess that is the kind of essence of kind of designing something, trying to make it as simple as possible. For example, along those lines, if we go back to, if you're, say you're building tic-tac-toe, for example, actually I do have an example of me building tic-tac-toe. It's got a board game. So let's go and have a look at that just as a side view. So I've got a book, Practicalli Clojure script. Oh, there we go, reagent. I'll put these links in as well. So this is a front-end application, but it's still Clojure, and we're still doing code in there. So if we look at, where is it? Square components, design, game board, design the game board. So I'm representing the noughts and crosses. Instead, I could use ones and zeros to make it simple, make it a bit more meaningful. I'm using empty and noughts and crosses to represent the 3 different states. And yeah, so I could hard code the board in there, but because it's a well-known pattern, then I can basically just I can use repeat 3 with empty. So it's going to generate 3 empties in that, and I can make 3 vectors of 3 empties, and generate the board there very simply. And so here I'm taking the list that gets generated here, and I'm just wrapping that in I'm just calling the vector function on that, which basically just generates the same values, but it just converts it into a vector rather than a list. And then I can basically generate the whole grid by repeatedly creating 3 empties. So this will create a list of 3 empty keywords, converts that into a vector. So it's generating this first part of the data structure. And then that whole thing here where we're going to repeat. So we're going to repeat that 3 times, and then convert. That would make a list of all these things, of all the 3 vectors, and then we're just using vec to basically convert that from a list into a vector as well. So this is a way, if you know the pattern is, if you know how to generate the data structure, then, or the values in that, then game board, there we go. Then you can generate those, and it's much more it's much more flexible in design, because we could feed in this value. We could feed, instead of hard coding it to 3x3 grid, we could feed in like a grid value here as an argument, and then we could generate any kind of like 3x3, 6x6, 9x9 size grid game board as we wanted to, 12x12, whatever. So we could generate a chessboard as well as tic-tac-toe and other kind of game boards that were like rectangular in shape. Okay. So I think I'm going to, because I haven't set some homework for a while, and hopefully everybody's going to do that, I'm going to ask you to think about how to solve this. And there's some ideas here in there, but to go away and come up with a way to solve this simple Clacks interpreter. So start by trying to encode. So you basically want to take a message. Let's switch back to Emacs. So take a message, which can just be a string. Take a simple message, and then I want to be able to see you convert that into a Clacks message. So there'll be like so you could create a function. More fingers and thumbs today. There we go. So like so message to message to Clacks, and then it's going to take an argument of message, and then how would you actually do that? So that's part of the homework, and so as a clue, probably want to oh, the kitty's back as well, so it's going to I'm going to have to go and sort him out in a moment. So as one clue is that rather than trying to break the whole message down, then so take each individual character from the message and then convert it. So you might want to create so you want to define a function from character to meow, clock, and then that is called as you go through and pass, as you're kind of passing basically each character from the message. So you might want to map or apply kind of something over some kind of function over the message. So that function would be ASCII character. Character to Clacks. Over the message, and then you just need to work out how to convert that. So one simple kind of way is to generate a useful map that you can use and give the map a name. So you want to kind of maybe define an alphabet, and then figure out how you want to represent it. So you can just represent that as a map with your keys and your values in there, and then how would you convert it? So so in here, how would you actually write the thing? Again, it should be fairly simple to kind of do use the map to do a lookup for each character, because this character Clack is going to take just a character as an argument. And so you need to write a function that will take a character and use that with a data structure to find out what its code is, what its Clack code is, and then using the map, it will bring all those back together, and then you get a code. And the actual code itself, the codes used and the structures used for codes, doesn't matter as long as it's consistent, and then because then as long as you can go in and decode, so you want to be able to decode something, so you want to go from so you need another function that will go from Clacks to the message again. So when the Clacks gets to the other side, so like if you're transmitting the Clacks to somebody else, then they can run the Clacks to message thing and get the answer in your English language. I mean, you could even use it for translating if your language still kind of has this intermediary language you can use. You could also translate in some ways as well. Or but if in this case we can just stay with the like same language, same English language, and so you do a like. So that's the homework for today, for this week, and I'll write a full. I'll do this myself and go like step by step through how I've done that and different decisions I've taken, and we'll cover that in more detail in the next episode. And if there aren't any more questions, then I'm going to leave it at that. It's a bit of homework for you. And feel free to reach out to me on YouTube, on the Slack channel for me to mentor, and or just generally on Twitter as well. I'm quite happy to discuss ideas about you have for this homework as well. Let me know, and thank you very much for listening.
John, what was that arrow symbol you used in your def?
Yes, I should mention that. Yes, yeah. So this is just a name of the function. So
is that the whole name of the function?
Yes,
I see.
It's kind of a convention that's appeared, a naming convention that's appeared. So all it means is it's a simple way, I guess, of writing. Instead of writing.
Instead of saying message to Clacks, you say, okay. Yeah, got it.
So we're just using this this arrowhead. Yeah, so this is not to be confused with.
Yeah, because I thought it was applying some sort of a.
Yeah. We could use that, but that's there's it kind of suggests that it's a core racing thing. So it's usually. This is a known kind of naming convention in Clojure, but obviously it looks
okay. So that's accepted by the community, and it's been used. It looks good actually when you use it that way. You can see the data being transformed from one abstraction to the other.
Yeah, exactly. Yeah, and it's quite common. You do see some of that in some of the existing functions as well. And there's quite a few like little name conventions. If you're using if you're doing the odd function, then it's got a question mark on the end of it. And any function that's in the core or any function that people have written that's got a question mark.
These are like Boolean expressions, right?
Exactly. Yes.
Boolean evaluating expressions.
Yeah. Okay. So they're going to return true or false values. In there as well, so they're referred to as predicates, which basically means they're a Boolean. They're working on an expression that's going to return a Boolean. And so it's just a nice simple way to indicate that you're going to get a true or a false. So you're asking a question: is this true or is this false? And the result is true or false. So, and I think that's. There probably are some other ones. I'll see. I'll dig them up for next week if there are other ones we've got as well.
Sounds good. This is an interesting one to do. It's not too hard. Let's see how it goes.
Yeah, it's not too hard, but again, if you do get stuck, try not to overthink it. Try and break it down into. It's a good exercise into thinking in Clojure as well, because if you take this approach, hopefully I've given you enough clues. So rather than trying to build just one function that does everything.
Yeah, I think it needs to be small blocks of composition of functions, and the small ones called the big ones called the small ones, and they call the smaller ones.
So one point I didn't mention is obviously that's going to have to be of function. So just to remember that Clojure evaluates things in order as well. It doesn't matter so much in the REPL, but when you're actually running your application, then if you're going to call a function, if I'm calling character Clacks here, then it needs to be defined before I call it.
That's like bash scripting.
Kind of, yeah. It's down to how the Clojure REPL works. So it basically just does a one-pass read of your code when you're running it. Obviously, when you've got a live REPL and you're developing, you can go in and just go in and evaluate it, and it doesn't necessarily need to be in the right order. However, when you actually run your application from the command line or in production, then obviously it needs to be in the right order. Otherwise, you'll get some errors when you actually run it. So it's good practice to always kind of, if you're writing a function and you're going to use a function that you haven't actually created before, then go in and just define it. Even if you just define it like this, without having to work everything out, at least it's kind of defined in the right place. That does actually evaluate. It's a legal expression. It doesn't actually have to have any behavior, although obviously you could just write it so it just returns. As we're generating Clacks, we could just have it return a string in that way, 0, 1, 0, 0, 0, something like that. So then at least it kind of just gives you a default answer. And you can use that with tests as well. So if you want to write some tests around this little application as well, that's a good way to practice it. And if I have time, I'll also write.
Yeah, I was thinking that well. Maybe it can be built up slowly by writing a few unit tests that gets a few of the Clacks characters. And yes. Then you give it a couple of characters, and then it does that. And then you've built your building block.
Yes.
And then you use them, and then you can refactor it to like minimize duplication. That's it.
Yes. So if you create a project, then you get a test branch as well with Lanyon. So I already have a core test file here as well. A little bit bigger. There we go. And so actually defining a unit test is pretty simple because we can just use the built-in Clojure.test library, and we're just referring all of that into to all the functions that are in Clojure.test. So we're just making them available in this namespace. We're including it. It's also included my namespace that we're going to test. So everything that we've defined so far, Clacks is under the Clacks.core. So we're just referring all of those things in. So we would be able to refer to alphabet, and we would be able to refer to character to Clacks and message to Clacks in this namespace because we're already referring those in here, and we can define a test. The test is just a function with usually with the name of the function you're testing, and then -test at the end.
What framework is it using? Is it the built-in core? What is it? Core test?
This is using this Clojure test. Oops.
Clojure test. Okay.
Clojure.test thing. So it's very simple. So how you write test is you write a def test function and give it a name. So this is usually if you're testing a specific function. So this, if we're testing character to Clack, and we'd change this to characters. So do that. There we go. There you go.
Blame that on your cat.
Yes. Yeah, so we'd write a def test like that, and then we can. You don't have to put the testing thing in, but the testing function is a way to group assertions. So this is like assert in JUnit and so on. So this is just the way to define an assertion. So is something going to be true? So is equal that 0 is 0 and 1 equal basically. And so is going to be returning true or false. If it returns true, then that assertion passes the test. And if is false, then that assertion has failed the test as well. So you can group, so if you're logically grouping your assertions, then this is what the testing stuff does. So you would put in a meaningful message. So you're testing, let's see, to the quotes, testing. That's a meaningful message in there, and then you can go in and say equal. So you know what A is. Let's see, A. Does A equal a character to oops. Oh, no, that's not right, is it? Yeah, so if I do characters like A, and that equal to the known pattern?
Should be the numeric representation of it, right?
Yeah, that's yeah. So when we call characters Clacks, do we get the right value? So that's a simple way to write kind of your first test, really. So and I think that would kind of more or less work, wouldn't it, with what we've written so far? Yeah. So that would probably. And then you can just run them. Let's see.
You have an error in the message. You've got 3 S's there.
Yeah. Oh yes, there we go. Yeah, when you evaluate these things, I should have picked that up actually. Autocomplete should help me do those, but I obviously ignored it. So the space 10. Then there are, if you use your editor, might have a test runner in there, and you can also use lining and to do your editing as well.
What is it? Lining in test, something like that.
Oh yeah, that's not the right thing. It's line test, yeah.
Line test. Takes ages. Failed.
No. Let's see if I run my test.
Tell you what, move to Brawl VM and then we.
Hey, there we go. So you might not be able to see it, but it's right down the bottom there. It's run the test. I'm going to run a test report. Where is the test report? There we be. What's it on that? Yeah. So right down the bottom, it's showing in green that I've run one assertion in one test function, and I've got 0 failures and 0 errors. So that's actually.
Whoa, that's 100% code coverage.
Whoa! Well, yeah, kind of. Except I've written a bit more code that isn't covered. So I need to do something for yeah. So
it's 200% code covered.
No, it's only.
No, it's 50% code coverage.
Yeah, something like that, or possibly less. So I could do the same thing for
What do you do if you want to put extra additional checks, like if you want to check for character B or C? I mean, of course, it doesn't.
Yeah, so you could do assertions
or multiple messages.
Yeah, so you could do an assertion.
Or just add another one on that.
Yeah.
Okay.
Yeah. So you just do multiple assertions, multiple.
Okay, the same way. Okay, got it.
Yeah. So like whatever's grouped, and you can also do different.
The commas you put in there, it means anything? Does it mean nothing?
It means I haven't written the code that I should.
Oh, and it's a valid how do you say expression?
Well, it's just white space, so Clojure will completely ignore it. So it's a developer hint.
But the is incomplete by using that, right? Will it then ignore that line?
Yeah. Well, I could probably just put is true in that way. Oh, actually, I should put is false, really, shouldn't I? Because you start with the
it'll fail if you say is false.
Well, exactly. So you start with a failing test, so you know which test you've
got. Okay.
You've got to fix. So you can do some selective testing of the conversions in here, and then if you write another def test where you're doing message.
Yeah, proper message conversions will require multiple tests just for the sake.
Yeah, And then so rather than character to Clacks, so you'd have message. You do some message, facts,
Message to Clacks.
and then you'd have rather than just an individual one, you'd have the
hello. So there's no representation of space, so the spaces will just fall out.
Yeah. So,
so that means there needs to be a test for space saying that. Okay. Anyways, we're going to the details of it.
Well, if you're going to convert it back again from Clacks, then you'll need to have some representation of space. So that'll be part of the design as well. So
maybe space can remain a space.
Yeah, I mean, if you're using keywords, then you might have to kind of create something that represents a space. If you're using string, then obviously you can use a space. You need to kind of decide which things are which of those choices you want to make as well.
Yeah, I can make these assumptions, and we can always change them if it doesn't suit us.
Yeah. So you would do this. That's some kind of.
You don't have enough representation there to do that.
Exactly. So you need to figure out what that was. So you write a test. So you could come up with an initial kind of thing as part of your an initial data structure as part of your test and build that way. And then you would need to do 2 more tests that were the basically the decoding. So these are, I guess, your encoding tests. So you're taking the English message and converting it into the fax language, and then you'd have to do like decoding.
Another one that takes the Clacks in and returns you the characters.
Yeah, exactly. So we'll so next week we'll do some talking about testing, and then go through the kind of solutions to this particular Clacks message as well. So we're combining the fun with map stuff we've done with some nice testing as well. And I'll mention some of the other test frameworks and test runners that you can use as well. But if you just wanted to test this, do it in your editor, or as has been mentioned as well, you can go into your command line inside the Clacks folder.
Is it normal for line to wait for a little bit before it gives you the results?
Yes. So when we do line, so you can do line rep or line run. In this case, we're going to do line test.
Line test. Yeah.
Then it's it does have to wait for the JVM to start up, which does
that's right.
Does take a few seconds. So yes, it's an amazing environment, but it's not the fastest thing to start up. So when you do line test, it's basically starting up.
Great.
Oh yes, I've broken it. Okay, interesting. Oh, it doesn't know what character to Clacks is because I haven't.
No, it's Clack. You put Clack, and it's actually Clacks.
Yeah, I also didn't evaluate those in the other. Yeah, okay. Yes, message Clacks. That should be right. That should be right there. So hang on. Message Clacks, is that wrong? Not able to resolve that, but it's complaining about
that's weird. Message to Clacks, because if you go back, you have a message to Clack. I think you don't have a message to Clacks. Go back to your core.
It says message to Clacks. So
you must have not evaluated it.
Yeah, that didn't evaluate. But that shouldn't matter for lining, because when you run line tests, it should just read the both files.
That doesn't make sense. It looks right. Message to Clacks. Go back to your ID, your test again.
Just check what it's saying. Character Clack. In this context, interesting.
So yeah, I think there's a character to Clacks, right?
No. Yes, it's in my test. It's the.
Show me your test, because I think you test.
So it's character Clack here. Did I get that wrong somehow?
Can you remove the arrow and see if it evaluates right? Just put a dash.
Oh, maybe I did that. No, it's not happening, is it? Let me go back to the here. Just copy that. Copy that from there. Oh, no, that's right, isn't it? Let's copy that. Tab. Oops, no, wrong one. It's that.
You must have not saved it.
Maybe not. Maybe not. There we go.
Save both of them.
Yes.
It's not auto save, right?
It's auto saves a backup, but it doesn't auto save the file.
So it cannot find Clacks.core. That's the problem. You see an underline under Clacks.core. Maybe it's called something else.
Yeah, I think this is my linter doesn't always pick up things. It's not 100%. I think it's talk about a new linter, so it doesn't always kind of pick up the messages. I'm going to check to see because it's not picking up def test either. But if I evaluate that, should have picked those up. But I think sometimes with macro, because this def test is a macro, sometimes that doesn't pick it up. That doesn't really explain why this isn't being picked up either.
But if you run that expression, is it evaluating the def test?
Yeah, it should be. So it's in there. So. So yeah, this.
I see you've got 3 brackets there. Oh no, you need 3 brackets. That's right. And do you need 2 brackets for that line with false?
No, that's the bracket for testing.
Okay.
Yeah, so yeah, that's the bracket for is, and that's the testing, and then that's the bracket for def
test. Okay.
Yeah, sure. Yes, it's picking up for some reason. It's not. So that's definitely right.
Wait. Remember, you had we had a similar problem when we created the package using line. We had to do something else, right? We had to do line new app Clacks instead of line new Clacks, and then when we build stuff.
Not sure why it's failing. That's a bit weird. Clack. I've obviously done something silly. I shall debug that rather than make everybody watch this. I'll fix it.
Maybe try doing this without those arrow keys, arrow symbols, and see if that's making a difference.
I wonder if the no. So it's picking up core test, which is the function that we've got. I'm sure that is. Let's just check the file names that are the same. Yeah, so this is core and it's called test, and the other one's just core, so that's fine. So it should be able to. So this is pulling core. This is called test. That's fine. I'm not sure why that's not doing that. Then that's very weird. So you mean rename these to?
Yeah, just for the sake of it, just don't. Yeah.
Yeah, there might be something funny it's doing with that. So let's try that.
And also in the not just here in the implementation as well.
Yes, that'll be interesting.
And save it. So then in the implementation as well. Maybe Java is kicking in and saying I don't like it.
It's surprising. I think the last time I did this, I didn't actually use the test, so there might be something that that causes a problem. Let's save. That's saved.
Now let's run it and see.
Let's do control and test.
See?
How bizarre!
All right, see.
Interesting. Let's have to make a note of that one.
Yeah, you got to tell the Clojure guys that it's it doesn't work.
Yeah. Cool. So that's how you'd run the tests anyway. That's how we get them working. So, and then you can also, specify just specific tests that you want to run. If you don't want to, if you get a large test suite, you can just specify a particular test that you want to run as well.
Okay.
And it gives you the it gives the expected value and the actual value.
Yeah, it's similar. It looks like similar to the JUnit way of writing tests.
And you can, I think, I'm not sure if you need a plugin for this, but you can also generate the JUnit XML reporting stuff.
Oh, okay.
For that as well. We did that. My last couple of places I worked, all the code. If you're running this through a continuous integration server, then you can run a plugin to this, which will generate the XML reporting output. So which is what most CI servers use to kind of show you which, like what have you failed, what's passed and failed in all your tests in their in their dashboard.
Test reports are for line managers, isn't it?
Well, test reports are like for CI servers and line managers. So this generates
CI servers and line managers. There's no difference between the two, isn't it?
Well, some people might say cruelly that CI servers have lots of additional functions. I'm sure line managers do as well. But essentially it just helps give like a visualization to anybody who's just looking at the CI server, what's passed and failed in terms of your tests. It does give you some nice feedback in that way as well. And there's quite a few different test runners, but we'll cover those next week.
Sounds good. That was good, John. You better take a break and cut it short, and let's speak next week.
Well, it's been an hour and a half. So again, thank you everybody for listening, and hope to see you next week. Thank you very much. Goodbye.
Take care. Bye-bye.
See if I can find how to switch it off now. There we go. Stop broadcasting.